The pH of a solution, which measures the acidity, is found by taking the negative log of H+, which is the concentration of hydrogen ions measured in moles per liter. pH of 7 is neutral, greater than 7 is called basic, less than 7 is acidic. So for an example here, we have the hydrogen ion concentration for a sample of human blood, and that's 3.16 times 10 to the negative 8. Find the pH and classify it as acidic or basic. So we just take our equation, find the pH, do negative log of 3.16 times 10 to the negative 8. Which equals about 7.5. Since that is greater than 7, it is basic. Another example of a logarithmic scale is the Richter scale, which measures the magnitude, M, of an earthquake. And to find out, you do log of I over S. I is the intensity of the earthquake, and S is the intensity of a standard earthquake. So the intensity of the earthquake is the amplitude reading taken at 100 kilometers from the epicenter, and then a standard is just considered to be 1 micron for the amplitude, 10 to the negative 4th. So in February 2010, one of the strongest earthquakes hit Chile. It was a 8.8 on the Richter scale. Just over a year later, in Japan, it was 1.6 times more intense. What was the measure of the Japan earthquake? So we are trying to find the magnitude of the earthquake. So magnitude is equal to log of whatever the intensity of the first one was in Chile. It's 1.6 times as much times what it was in Chile, so let's call it I, over the standard. That would be the magnitude of the Japan earthquakes. So using our logarithmic rules, since we are multiplying here, we can split that up to addition. So we could do log of 1.6 plus log of I over S. Remember, this I and S, well, S is standard, but this I was whatever it was in Chile. So this whole thing would just be the measure of what it was in Chile, which was an 8.8. So it's log of 1.6 plus 8.8. And log of 1.6 is 0.204. Plus 8.8. So that means that in Japan, it was a 9.0, but it was over 1.5 times more intense, just in that 0.2 scale. Another logarithmic scale is the decibel scale. Decibels are just how intense the sound is. So the intensity of the sound equals 10 log I of I naught, where I naught is the reference intensity, which is 10 to the negative 12, so you can always think of that as 10 to the negative 12. And that sound is just barely audible, so that's what we refer everything to. So find the decibel intensity of a jet engine during takeoff. The intensity was measured at 100 watts per square meter. So if we convert that, that'll be 10 squared. So the sound intensity, decibels, is equal to 10 log 10 squared over 10 to the negative 12, the reference. Now you can simplify this. 10 squared over 10 to the negative 12 is just 10 to the 14, because you would subtract 2 minus negative 12. And then log and the 10 cancel out, so this is really just 10 times 14, which is 140. So a jet engine during takeoff is 140 decibels.